In the 17th century, man went beyond mere thinking. He began to act. His philosophy became, seeing is believing. He invented the telescope, and this magic instrument greatly extended his range of sight. He saw mountains and craters on the face of the moon. He found that the planet Venus also showed phases just like our moon, and that Jupiter has moons of its own. He saw for the first time the reddish disk of Mars and the beautiful rings of Saturn. With a telescope, man discovered the universe in all its unbelievable richness. At about the same time, a second powerful instrument was invented, the microscope. It opened up an entirely new and tiny world for man to explore. It was a world full of strange patterns and designs. Man found them in ordinary things such as wood, in the feathers of birds, in the bodies of insects, and in the scales of fish. The microscope revealed infinite details in everything. There was hidden beauty in miniature seashells, so tiny that millions of them form only a wisp of powder. Even a single drop of pond water revealed forms of life never before seen. Tiny, one-celled animals and plants. The microscope gave man his first look into nature's miniature universe, a world teeming with fantastic forms of life. With the microscope, man also discovered the beautiful and regular forms of crystals. He marveled at the delicate shapes of snowflakes. In thousands, no two are alike. In the regular shapes of crystals lay hidden the secret of the atom's existence. Of course, the microscope doesn't show atoms. They are much too small for that. But it made man aware that everything he saw and discovered must be composed of something still smaller. One of the first men to explore nature's tiny realm was John Dalton, an English chemist. This was early in the 19th century. It was he who revived the idea of the atom.
I believe Democritus was right. All things are made of atoms. Take copper, for instance. My drawings show how the atoms group together. They are like little, hard, indestructible balls with some unknown force acting between them. When the atoms pack together, layer upon layer, millions upon millions, then they build a tiny crystal. And when the crystals combine, they form the copper metal we are so familiar with.
And there are also atoms for silver and gold. There are different kinds of atoms everywhere. Atoms for sulfur in a match. Atoms for carbon in every ordinary pencil. Atoms for mercury in a thermometer. A different kind of atom for each element. But most of nature's creations are mixtures. This glass is a mixture of different kinds of atoms. The wood here, another. This book is composed of more mixtures than I could name. The secret of how nature creates her mixtures was first understood in 1811 through the work of Amadeo Avogadro of Italy.
When atoms of different elements combine, they form into small, compact masses, which I call molecules. I have found that there is a different proportion of atoms for each kind of molecule. For example, when one atom of oxygen combines with two atoms of hydrogen, they form the most common molecule in nature. This, of course, is H2O, water.
It takes billions and billions of these water molecules to make a single drop of water. They are so tiny that they cannot be seen even through the most powerful microscope. However, the microscope does reveal an important fact about atoms and molecules. It shows that they are in constant motion. These are dust particles in a drop of water, and you can see that they are being kicked around by the ever-busy water molecules. It was over 100 years ago that an early microscope first revealed that atoms and molecules are constantly on the move. Now in a flame, for example, the motion of the atoms and molecules is extremely violent, and this is why a flame is hot. Our skin is equipped with tiny organs that can feel this violent movement as heat or even pain. Now in this glass, the molecules are moving much more slowly, and so it feels normal to the touch. Even in an ice cube, the molecules are moving, but very slowly, and this is why the ice feels cold. Let's look at heat with an atomic eye, so to speak. Atoms, of course, don't burn up. They merely rearrange themselves, forming molecules of soot and ashes. So that you can see what is going on, we will exaggerate the size of the atoms over 1 billion times. The molecules in the flame dash around with great speed and bounce against the molecules of the glass. They transfer their violent motion to the glass and finally to the ice. It's like a pool game with the balls bouncing against each other. If more heat is applied, the ice molecules will move faster and faster and finally break loose from each other. The ice melts. As the movement becomes more violent, the water begins to boil. The molecules are kicked away from the surface as steam. In hot steam, they're dashing around with great force. Enough force to bounce the lid of the jar. There is power in steam. Power that can do more than just lift the lid. When this force was put to use, it ushered in the mechanical age. It was the power of steam that turned our generators to produce electric power. And the gaslight era then became the age of electricity. True, steam was a mighty servant, but it was a hungry servant. It had to be fed constantly, and satisfying its hunger cut deep into our precious resources of coal and oil. Man had not yet found the genie of our story. In fact, he hadn't even found the vessel in which the genie was imprisoned.